Okay, good morning everyone. Today I am here to give a talk on comprehensive overview of the latest features and improvements of Postgres 16 version. Yeah, a brief introduction. My name is Shruthi and I work as a database engineer at Enterprise DB. I've been working on database for a decade and a half now, and my journey with Postgres is quite pretty young. I started working on Postgres from past 3 years. Okay, before I get into the actual agenda of today's talk, I would like to give a little background on open source PostgreSQL. PostgreSQL is a powerful open source relational database with 35 years of active development. The power of any open source project, it comes from the community it surrounds with. When developers and even companies with different backgrounds and unique perspectives come around collaborating, making a technology, the result is a code which is richer, more secure, and more robust. Postgres has its strong reputation for feature robustness, reliability, and performance, and that's why Postgres is named as the most admired and desired database. All new features and fixes that get committed into Postgres is thoroughly vetted by a community of contributors and committers. And Postgres is free to use. Anyone can start downloading and use it for their applications. So there is a wealth of information available in the official document where it has in-depth knowledge on how to set up Postgres and how to use it. Also, there are many mailing lists where you can, if you wish to connect with the community and interact and contribute, you can subscribe to that and contribute there. And also, there are many events and local user groups where you can connect with the other PostgreSQL users and interact with them. So next, I'd like to talk upon PostgreSQL releases and lifecycle. The PostgreSQL global development team releases a major version every year. And for each major version, we receive a minor version, which mainly includes bug fixes and security fixes, which would happen every 3 months, which is called as a minor release. And the major versions are supported for 5 years from the date of release. Once the 5 year is completed, one last minor version is released, which includes the bug fixes before the release goes into end of life. And if someone is building a new application, it is recommended to start using the latest Postgres major version, so that this guarantees that the Postgres has the latest and the greatest features, and also the continuous inflow of bug fixes through minor versions will make sure that application is robust and secure. Yeah, we had our latest major version release, which happened in September 2023. As every year, this year also, we have a lot of exciting features and performance improvements. And I feel it is an honor to be given this opportunity to present that in front of you all. And the complete list of the changes, performance improvements, and features, you could refer to the press release and the release notes. So now I'll start with the actual agenda of today's talk. So we have a lot of improvements in logical replication, monitoring enhancements, optimizations and performance improvements, localization and enhanced JSON support, and access control and privilege administration overhaul. So the first area which I would like to explain is improvements to logical replication. Before I get into the details of what problems and bottlenecks Postgres 16 is going to address, I would like to touch upon what is logical replication. Logical replication is a key feature of Postgres, which provides a flexible solution for data replication and distribution. It provides a granular approach where users can subscribe to data from multiple versions of Postgres. Also here, users can decide to what extent it wants the data to be replicated, be it like a single table, a group of tables, specific operations, or even set of records. See, the logical replication follows subscribe and publish model. As you see, a publisher node is where a publication is created. Publication is nothing but the list of data objects which a node wants to publish. Like I mentioned, it could be tables, records, operations, and a subscriber is where a subscription is created. A subscription tells that from which publication this node wants to get the information to be replicated. A subscriber can subscribe to multiple publications, and at the same time, a subscriber can be a publisher as well. So once the initial publication and subscription is set up, the initial synchronization happens. The snapshot of the data from publication, publisher node is transferred to, copied to the subscriber node. This is called a stable synchronization phase. Once the copy is done, the subsequent changes to the publisher is sent to the subscriber as and when it occurs in the real time. And in subscriber, these changes are applied in the order of the commit so that the transactional consistency is maintained. So now I'll be starting with the improvements we have in logical replication. The first one is bidirectional logical replication support. So bidirectional replication support is a two-way data exchange. As you see, like we have node 1 and node 2. So node 1 will subscribe to, node 1 is a publisher and node 2 has subscribed to that changes. At the same time, node 2 can publish the same data and node 1 can subscribe to that. So which means any changes that happens in either of the node, it is mirrored to the other one and vice versa. So before to PostgreSQL, what happens is, for example, an SQL is executed in node 1, it is executed in node 1 and it is sent to node 2, and in node 2 it is replicated and its changes are applied. Now since node 2 is a publisher, it is going to send back the same data to node 1, and this will result in an infinite loop of exchange of same data. And this happens if the table did not have a primary key. And in case there was a key on the table, then it would the logical replication would fail with the key error. It will fail with primary key error. So this would happen earlier because the apply worker could not distinguish whether data originated from the local node or it was received from a replication process. So how this problem is solved in PostgreSQL is that while creating the subscription, you could mention what sort of records information you want to replicate. So there is a new option called origin, which takes two values. When none is mentioned, it requests the publisher to send only those changes that has no origin associated. If any is mentioned, then it means that send the changes regardless of the origin, which means it is same behavior as it was before to PostgreSQL, and that's how this issue is solved. Next improvement we have is support of logical replication from standbys. In the earlier versions, replication was supported only on the primary nodes. So now in PostgreSQL, we have standby nodes can also do the logical replication. So we can create logical replication in standbys, and also we can create subscription to the standby node, and other nodes can subscribe to the information from the standby node. And one notable, one highlight here what we can see is, even when the standby promotes to primary, the connection can remain as is, and the subscribers can continue receiving the data from the newly promoted primary node. And this is expected to reduce the load on the primary server. Next improvement is parallel application of large transactions. Before in earlier version, only when the transaction was committed, the transaction was transferred to the replica. But here we have an option as streaming. So this option will enable the streaming of in-progress transactions for the given subscription. By default, this is not enabled. And if you set parallel to that particular, for this new option, then the changes are directly applied via one of the parallel apply workers, and this worker remains assigned till the transaction is committed. So the performance improvements of range 25 to 40% has been observed for bulk data streaming, and max parallel apply worker per subscription determines the maximum number of parallel apply workers for a given subscription. So this is the syntax to enable this option. Next area of improvement is binary copy. So now logical replication, you can do the initial table synchronization in the binary format, which was not possible in the earlier versions. So this again has, it has performance improvements by 30 to 40% for the initial data synchronization in the replication. So for this, you need to set binary as true while creating the subscription. Next improvement is allow indexes other than primary and replica identity on the subscriber. So when you have replica identity full on the publisher, this could lead to a full table scan on the subscriber for each change in the primary when replica identity or the primary key was not available on the subscriber. So now in Postgres 16, subscribers can use B-tree indexes for scanning so that sequential scan can be avoided. And again, this change is definitely going to boost the performance of logical replication. So next improvement in logical replication is with coming from control enhancements. So the non-super users can create subscription. To do that, we have a new predefined role in Postgres 16, that is PG create subscription. So when a non-super user has been granted with this role, he can create subscriptions. And the non-super user is required to specify password for authentication. And the super users can set password required is equal to false for those non-super users that own the subscription. So the last improvement in logical replication I would like to discuss is with respect to table owners privileges. Now in Postgres 16, the apply process can be configured to perform with table owners permission, whereas in earlier version it used to be allowed only with the subscriber owners privileges. In order to enable this, you need to mention run as owner as false while creating the subscription. Okay, this is the second area of improvement, that is monitoring enhancements. The monitoring capabilities in Postgres 16 has become more detailed and insightful. The introduction of this new PGStat.io view is a testament to this. This view gives the comprehensive overview of the I/O statistics that is happening in the system. So for data administrator, this gives a holistic and a detailed view of his operations, and using this information, a lot of performance tuning can be done, and this is going to help in database optimizations. So when PGStat.io view, when you query this when you try to get the information from this view, you can get a number of rows where each row will have a combination of backend type, target IO, and IO context. Backend type, the possible names are background worker, auto vacuum worker, checkpointer, and target IO objects are temporary and permanent relations, and IO context would be normal, vacuum, bulk read, and bulk write. PGStat.io gives information about a lot of IO operations like reads, writes, evictions, hits, fsyncs, reuse, extends, and so on. So now using this data, you can try to configure and understand where the configuration is not right. So for example, a high eviction count can indicate that shared buffer needs to be increased, and also a large number of fsyncs by the client backend. It indicates that there is some misconfiguration of shared buffer and the checkpointer. Along with PGStat.io, there are other existing views which has got updates and improvements. For example, two new fields called last sequence scan and last index scan has been added to PGStat all tables. So this records the timestamp of when the last time the table was scanned. And also there has been improvements to the accuracy of query tracking algorithm used by PGStat activity. Okay, here is an example of how PGStat.io would look. So you can see that you have backend types, objects, context where you have bulk read, vacuum, normal, and you have reads, writes, extends, hits, evictions, and so on. So next area is localization. Postgres 16 improves the general support for text collations, which provides the rules for how text should be sorted. And also Postgres 16 by default builds with ICU support, and it can determine the default ICU local from the environment. And also it allows users to define custom ICU collation rules. So next area is enhanced JSON support. This release adds more syntax for SQL JSON standards like constructors like JSON array, JSON aggregate, JSON object, and JSON object aggregate. Also, it introduced the ability to use underscores for 1000 separators, and also now you are allowed to use non-decibel integer literals. And it also introduced a new command called /bind. So using this, you can now prepare parameterized queries where /bind can be used to substitute variables in PSQL terminal. Also, there are a few JSON predicates added. It is JSON, so each JSON value, is JSON scalar, is JSON array, is JSON object. So this helps to determine whether the input is a value, scalar, array, and so on. So here is a sample of how this new predicate could be used in while designing. So next area, in this area, I have considered a couple of performance improvements. The first one is bulk loading. So this release brings significant improvements to bulk loading using copy command, and this is applicable for both single and concurrent operations. So certain tests have shown a remarkable performance enhancement of up to 300% in certain cases. The second one is CPU acceleration using SIMD in x86 and ARM architectures. So again here, notable performance has been observed while processing ASCII and JSON strings, arrays and subtransaction searches. The third one is allow vacuum analyze to specify buffer usage limit. Here a new option called buffer usage limit is added, where you could allows user to specify the size of the shared buffer. Also a new GUC named vacuum buffer usage limit is added. So this again is used to control the size of the buffer when buffer usage limit is not explicitly mentioned. Fourth one is improved vacuum. So here there are some improvements like during non-freezing operations, perform page freezing when appropriate, so that this makes that full table freeze vacuums less necessary or wanted. So next we'll see what improvements we have for load balancing. To enable load balancing across multiple servers when using libpq, this PostgreSQL has added a new feature called load balance host. So while using this new feature, if you provide random as the value, then libpq will randomly try to connect to different hosts and their available associated IP addresses. So this will definitely help to distribute the workload when there are multiple clients and frequent connections are necessary. Also, it is recommended to configure the connect time appropriately, so that if one of the node is not responding, a new node will be tried. So next we see what improvements we have when it comes to query planner and optimizer. The first one is incremental sorts for distinct queries. So prior to PostgreSQL, when sorting method was chosen for select distinct queries, the planner would consider performing a full sort, which is more expensive. But in this release, the query planner considers performing an incremental sort for select distinct queries. So here is a sample test where you could test this particular optimization. So I have tried to execute the same in PostgreSQL as well as PostgreSQL. So this is the explain output. So you can see that almost there is a performance improvement of 60% for this query when compared to previous version. Next is faster order by distinct aggregates. So earlier, when aggregate functions had order by or distinct, the executor would result the sorting to be done in the aggregate node of the plan. But in PostgreSQL, planner now tries to make a form such that the sorted or the already sorted rows are passed to the planner, aggregate node in the correct order. And also the executor nodes is smart enough to know that the row is already sorted, and it will let go of the sorting inside the aggregate node. So here is a sample test, and again explain output from PostgreSQL and PostgreSQL. So here also an improvement of almost like 50 to 60% you can see. The third one is allow memoirs atop union all. So memoize is when same value needs to be looked upon several times. Memoize can give nice performance boost so that it can skip executing its subnode when query required rows have already been available. So in Postgres 16, memoize is used in union all queries. So here is a small test, and there is an almost the execution time is 6 folds faster in Postgres 16 compared to Postgres 15. Next is parallel hash full and right joins. Postgres 16 allows full outer join and right joins to be performed in parallel. When this test was run on Postgres 15 and 16, there was again a performance improvement of almost 60% observed. Fifth one is support right anti-joins. Earlier in versions, when queries had non-exist in part of the query, so the table inside the non-exist was always considered for generating the hash. So this would sometimes make the considering larger table for generating the hash. But in Postgres 16, the planner can now choose the smaller table to generate the hash, so that this can this is now possible because the Postgres 16 supports right anti-joins. So if you see the execution time, it is almost reduced. So it is like 2 times faster compared to earlier version. The last one is allow left join removals and partition table. Postgres 16 allows left join removals optimization with partition tables. The performance observation is that there is like in Postgres 16, it is almost 10 times faster compared to Postgres 15, this particular query, which has union all. Next, we'll see what improvements we have in access control and security. A new libpq connection is added, which is require auth. So this will allow you to specify list of acceptable authentication methods. And one more member is added for libpq, that is SSL cert mode, which allows the transmission of client certificates. So the options valid for this member is disable, allow, and require. And also PG16 allows regular expression matching for database names and role names in PGConf file. And also it supports Kerberos credential delegation, allowing extensions like Postgres, FDW, and DB-Link to use authenticated credentials to connect to trusted services. Next is privilege administration overhaul. The administrative privileges in Postgres 16 has a tremendous transformation. Historically, a lot of administrative operations in Postgres required super user accounts. This approach, while functional, posed a lot of problems when in larger organizations having multiple administrators. Postgres Restream addresses this problem by refining the rules and user rules and privileges. So we have a lot of improvements, and have here are a list of few which I have selected. So it allows alter group name, add user, username to be performed with admin option. Previously, create role permission was required. It allows the create role to automatically inherit the new role's rights or the ability to set role to the new role. So this is controlled by a server variable called create role self grant. And it allows grant to use with admin true false syntax. Before to Postgres 16, we only had with admin option. Now we can specify whether it to true or false additionally. It allows users to change the default privilege of only inherited roles, not non-inherited roles. And the last one is add grant to control permission to use set role. This is controlled by a new grant set option. So this is the last section. So what we can expect in Postgres 17 in our next version. So this is based on the observations and discussions happening in the community, and this is not a final list. So we could expect incremental backups, And there are a lot of work going on in logical replication, which includes DDL replication, replication of sequence, reuse of table sync workers, and so on. And we had a lot of SQL JSON improvements in Postgres 16, and we can continue to expect the same for Postgres 17 as well. Some improvements in vacuum technology and partitioning, and improve the statistics and monitoring, and SLRU optimizations, improve blocking for better scalability, enhance stable AM APIs, and toast improvements. Yeah, that's all I had for today. Thank you. Yeah, any questions?
So, Shruthi, I have one question related to this bidirectional replications, right?
Yeah.
They have supported. Don't you think like bidirectional replication can cause conflict? How they do resolve this conflict resolution when same group of tables is changed by both of the sides?
Yeah.
Are they consider that part in this particular bidirectional support?
Yeah. Sorry, I didn't get.
So consider like both the side, both publisher and subscriber now both can exchange their data, right?
Yeah.
Bidirectional things, right? So scenario can be like both the guys try to modify the same table.
Yeah.
Okay, there is a conflict will come, right? Both are going to exchange this information, sir. So are they this type of things scenarios is handled in this bidirectional case, or they just fail it? So they handle the failures, or okay. So they have not taken care, is it like that? Okay. Okay.
Yeah,
Okay.
it's not supported in this version.
Hi. So I have a question regarding the load balancer capability you provided.
Yeah.
I mean, you showed. So you mentioned that there's a mode called random. So are there any other values that we can specify and how they will work? Like for example, if I want to choose a node to be connected based on the load on that node. So is this possible?
That is not possible currently.
Okay. Yeah. Thank you.
Great talk, Shruthi. Thank you very much. What was your favorite new feature in Postgres 16? Which one were you the most excited about?
In Postgres 16?
Yeah, the new of all the features you presented. Which one?
Logical replication.
Okay.
All right, that's it then. Thank you all. Thank you, Shruthi.
Thank you.